you go. Well, thanks everybody for sticking around for second session. I'm a little bit reporter as a consultant, but I'm happy to introduce Alex, who is the CTO of Customaite, which is a SaaS product we are building from inside IA. I'll let Alex explain what Customaite is all about. He used to be also an engineering manager at Uber Freight, and he's going to talk to us about reactive virtual threads. Yeah, and honestly, I have no clue what that is, so looking forward to it. It's a whole new world for me.
We'll keep it light. And so thank you everyone for joining. I only just learned it's the BDEN meetup, not the BDEN meetup, so I can change a couple of slides during your break. Get some in. We're good to go. We can still talk about our journey from Reactive Codebase to virtual threads. Why do we do that? In our case, it was to simplify code and developer experience. What is Customaite? We are an application for customs declarants. So as goods are moved in between customs unions, someone needs to declare those with the right authorities. And that entails going through a lot of paperwork, making a lot of links between different items and good lines, summing them up, etc. Just so that they can make the good declarations with the right tariff codes, for example. So that's what we do. How do we power it? The backend services, they're a mix between Python and Java services. So of course, for the data stuff, use Python. Especially that one is CPU heavy for all different types of algorithms. And then for our domain services, stuff going to end users, enrichment, calls going out, we use Java and then we use the Quarkus framework. So this talk is about the latter, about Quarkus. Some of the challenge we had with the Reactive framework, the Quarkus, back at the time that we started Customaite, 4 years. At that time, it was still the default. Why it became famously known as Quarkus within the team, and how we made this tool work better for us. Shortly about me, Bert talked about biases. So what are my biases? I'm an enthusiast about Go's simplicity, for example, and Go is also known for its coroutine model, so for lightweight threads that you can spin up to do work. So I was very eager to see how Java's virtual threads measure up to them. I got to use Go at scale at Uber before, and I also had experience with Node.js at Cardiogram, and then mostly Java and Node.js before. So what was our problem? What was our problem with reactive complexity? Before we dive, we'll go into the weeds about reactive threading and reactive frameworks. Let's talk about the more, let's say, common model, which is where the JVM, Java Virtual Machine, spins up a certain number of platform threads and reuses those for all requests that come in. And typically, each request, be it HTTP or something, let's say from a message bus comes in, will be assigned one platform thread. Every platform thread will be associated with one operating system thread. How many of those? That depends on your CPU and how many cores you have, how many threads per core. That will determine how many of those are running around. And in that case, it's the CPU that's responsible for scheduling the work. When there's more work that wants to be done, then there are, let's say, what's available. What's Quarkus? Quarkus is the application server built by Red Hat. So around 2019, I saw on Bert's slides. What are the main benefits there? As you can see, with reaction, let's say, from the rise of Kubernetes and cloud native and so forth. So they made a lot of changes to make it easy to pack into containers and deploy to Kubernetes. Perhaps pack up native application, native Java images so that they are smaller in size, start up faster. Next, they want to focus on developer joy with, let's say, integration with dev services, spin up a container of a database if you're working with Hibernate. And then the other main benefit is performance. How do they do that? Well, with the reactive core. So if you use the reactive framework as advertised, you will see benefits in performance. Instead of the classic threading model that I showed earlier, Quarkus uses Vertex. And for those who are using Node.js, if any are around, this will look very familiar. Whereas Node.js is just, say, the single event loop. In Vertex, you also have this model where you have event loop threads and worker threads. And reactive code is running on the event loop. Events come in, it's quickly dealing with stuff. It encounters, let's say, blocking I/O because there's a request going out to the database or a request going out to a different server. It'll register callbacks and just file it off, pick up the next event, and then when the server comes back, the database call will just be added, let's say, as a little circle at the top, a new event coming in. So the event loop is continuously busy because it can deal with I/O in a non-blocking way. If you're doing, let's say, CPU intensive work, or there's code that's not reactive, then you need to ship it off to a worker thread. And then when that work is done, then it comes back to the event loop to get a response to the end user. So to write code that runs well on the event loop, you need to use reactive code. And for Quarkus, the team wrote their own framework, Mutiny, which is a portmanteau of uni and multi. So in this case, what can you see here? It's a lot of chains and also nested chains. You know, the order is very important. You need to nest them, of course. You need to use the right chain commands, like say transformations, depending on what needs to happen. Is it a fire and forget call? You can't use your classic try catch like normal mortal human beings. You need to write, let's say, the failure hooks as well and hook them in. And as you might, for someone who's used to this kind of code, you might drop this immediately, but this does increase, let's say, cognitive load, especially for a new team or new people coming to the team as well. And it's also very easy to shoot yourself in the foot with this kind of, let's say, more complicated code. There's also a stack traces look. So one of the issues, say, with this work switching that much between, let's say, worker threads and event loop threads, is that the stack trace isn't growing linearly. It's being run on different places all the time. We saw cases of, say, contacts just getting lost. So we wouldn't see, let's say, specific log statements. Usually the fix to us was just to switch the code to the synchronous variant, and a lot of issues would be fixed this way. Those are things that, for us at least, contribute a lot to developer experience. So for us, the developer joy one with the Quarkus Mutiny framework wasn't working out that well. I mentioned some of these challenges. So there's a steep learning curve with this kind of programming. Very easy to shoot yourself in the foot. There are very few event loop threads. So if you happen to write, let's say, blocking code there, the event loop will get stuck and your performance will deteriorate. Difficult to debug stack traces. We would see logs disappear, or when we use Datadog for distributed tracing, we just, let's say, empty blocks where calls to other services would get lost because the trace ID that's stored in thread context would not always be propagated. And there's also another problem that is, if you really want this to work well, there's, let's say, a need for it to be reactive all the way down. Let's say, to need your Hibernate, so your library for going to the database needs to be reactive, your REST APIs need to be reactive. And those, at the time, talking about, say, about 3 years ago, they were not production ready either, like the Hibernate reactive one. I think today they are, but it was also an issue for us at the time. So the writing on the wall was there. Project Loom has been around for a pretty long time. And with Java 21, they finally released it 2 years ago to a LTS, a long-term support version. And we think the team at Quarkus also saw the writing on the wall because they think we're relatively quick to jump on, let's say, virtual thread support for Quarkus. And they also now no longer, I think, promote, let's say, Mutiny as a default. I think now it's just, let's say, the synchronous variant with virtual threads. I think there's also good reason for that. So what are virtual threads? I think most of the people in the room work with Java. So, please raise your hands. Do you use virtual threads production? All right, excellent. Then this will be useful, hopefully. Start Java virtual threads. So we saw the earlier example of the platform threads. So every request is tied to one platform thread. The issue is here is, what if the platform threads are saturated? Well, then the next request will just have to wait. In Java, they build an extra layer in front of it, virtual threads. So the platform threads, which I'll refer to as carrier threads now, they're expensive to create and spin up. So the JVM will create new of them if it's needed. But it's like, say, 2 megabytes in size, takes a while to spin up. So it's not intended to be used, let's say, to be spun up and discarded. The virtual threads are. They're quick to spin up, just a kilobyte or two in memory speed, and they are intended to be used, let's say, for a single request and then to be discarded. Depending on, let's say, your workload, let's say you need to do, like, say, 10,000 things, I wouldn't just spin up 10,000 virtual threads. I would, aggregate them in more like kind of fan-in worker patterns there. But in the case of, let's say, HTTP requests, yes, do I want to a virtual thread. One other ability of virtual threads is that they can yield. So let's say we have one carrier thread at the top in blue, and then we have 3 virtual threads. So let's say 3 HTTP requests coming in at different times. The first one, it'll request CPU work, and then let's say 100% one. And at one point, it'll do, let's say, a database call or another HTTP call somewhere else, and the thread will be marked idle, and it will yield. It's a sign for a JVM to know I can unmount this virtual thread, and if someone else needs work, I can mount it on that carrier thread. So it's a case of that performance boost we saw earlier. So the reason also for the Reactive framework is to more efficiently plan work on the CPU when threads are waiting for events from the outside. So this is a different way of looking at it from the virtual threads perspective. The main advantage is you can still write synchronous code. So let's say this reactive variant then becomes, ta-da, with one annotation run on virtual thread. You can just have your synchronous code like us mortals are used to it. You can put everything in one single try catch, and you can be sure that nothing escapes it. And we do find it reads a little bit easier. Okay, so what's the catch? I don't have to learn all this reactive stuff. I get performance boosts. What's up? One of the main, let's say, dangers initially, also when 21 was announced, was, well, this does work great, but you have to be careful for the risk of pinning threads. Code that is running in synchronized blocks doesn't yield. So that means that one virtual thread could, keep one carrier thread hostage while it's waiting for blocking I/O. So I think that was a scramble in the Java world, and a lot of libraries had to change. I think that was one of the reasons. One of the final things Quarkus was waiting for, I think it was, let's say, the database transaction manager making some changes. I know because I was watching those, let's say, issue threads until we can finally try it out and make use of it. So that's one thing. We didn't really encounter it thus far. Another one is that this is mostly a performance boost, of course, when your main limitations are waiting on input-output. If all you use, let's say, just a lot of CPU intensive work, then there's not as much advantage because a virtual thread will just keep a carrier thread until it's done. It might also not be that much cost on your use case. Okay, so what are some virtual threads implementation patterns? We'll go into some quick demos later, and they're centered around 3, let's say, main parts. The first one is handling incoming requests, and this one is pretty easy. That's just adding the single annotation that I mentioned earlier. The second one is distributing work, and that one gets trickier. So even though virtual threads is out since 2 years in LTS version, to make the next 2 things work, you need some features that are still in Java preview. What does Java preview mean? In this case, they are production ready, but just know that they might change your APIs, and they have, just in slight ways. So that's something that does happen. So the first example is how you distribute work. So I need to do 3 things, and I want to continue when all 3 things are done. And the second one is, well, yeah, I want to do those 3 things, but I also want to make sure that all this context that I build up, let's say from a request scope being, can be the customer in a multi-tenant environment, can be the user. I want to make sure those are propagated, and you need another preview API feature for that with scope values. So I'll just, let's say, briefly go through them, so at least you know they exist. I don't expect you to remember the syntax. Okay, let's jump to IntelliJ over here. So this is one application with, say, 3 endpoints. Let's.
Can you zoom one?
Yeah. Oh, I have to remember the shortcuts. Yes. That good? Oh, it's not this one. It's the. There we go. Okay, so there's three. Those look too complicated. I have three endpoints in here. One is reactive. You know it's reactive because it returns one of those unis. The next one is blocking. So in Quarkus, you can also indicate, something is blocking, and then it'll use the classic platform thread model that I talked about earlier. So this one does blocking operation. What is blocking operation? Does a thread.sleep for 200 milliseconds. Then we have the same one. Does exactly the same thing, but instead of blocking, I do run on virtual thread here. And then I have the reactive one. It does something similar to thread.sleep. I can't just do thread.sleep because I'm actually blocking the event loop, and then I'm causing disaster because it'll really impact the performance. Then I made a script in a superior language. There are some limitations to doing these tests locally because the objects need to be loaded in the JEM. Garbage collect could be happening. There could be other stuff like Bitcoin mining running on my PC that might cause some CPU spikes. The general idea is I'm running tests, let's say, up to 1,000 connections to each of those endpoints and to see where they break. So for the blocking one, I'm starting up connections in different Go routines. And then we see that around 450, it fails, well, it indicates failure because the latency is almost double that 200 milliseconds that I talked about earlier. So around 250 to 350, we start to see those platform threads getting exhausted. Let's see the next example then, just by making the blocking annotation and run on virtual. And every request is now running on a virtual thread that'll yield when it's waiting. And now it's doing a lot better. It's going up to 1,050 here until it starts to return more connection errors and latency increased. But we can already see from this very basic example that this is quite the boost. How does the reactive one do? We will see it should perform sort of similar. You can't really measure the margins at this kind of level. You would need to do that on production. Maybe shift your traffic between two versions of application. But yeah, it'll be a very similar example. So using more simple code, let's say, you can get in those performance benefit range of virtual threads. That's nice, of virtual threads, of reactive code. That's pretty good. Let's jump into the next example, which was structured. So in this case, I'm setting something on a request scope beam, saying, this is Mario. Mario is making the request. And then the easiest way of spinning up a virtual thread is just doing thread.virtual start. I say the user is from the context. I try to get the user again. I do a sleep. And then if you don't do a thread.join, so join is the language of I will wait here at this point until you finish. It'll return immediately. If I would do this, then I would wait for that single thread to complete. In interest of time, I'll just actually no. This one is important because it needs to do the curl request. Oh. Which other point this is again? Virtual thread. And this one is fire forget. Did I actually make it fire and forget? Yes, I did. Okay. Oh yeah, now I need to switch to the application here. Oop. Let me see. Oh no, the user is null. It didn't actually get that context from request scope being when I started my virtual thread. So we'll look into a way to fix that later. Let's say I don't have one virtual thread, but I have multiple. Oh, there you go. Let's say I want to do multiple tasks. So in this case, I have one locking operation and I have a second one, and I want to wait until both are done. You could do stuff like, say, managed executors, like you have before in Java world. But the Java authors themselves, they also saw an issue with structuring work. Getting an idea of these two tasks belong together. If one of them fails, please fail everything and don't continue endlessly. Or you might, for example, want to have 3 tasks or 5 tasks and put up a deadline of 10 seconds. And if the deadline has been reached, we don't care about the work. Please interrupt it immediately and let's return the results that we do have. So that kind of work they built a structured task scope. Oof, I'm not going to read that right now. So for again, there we go. So you see all these yellow wiggly lines because it's preview API. So your IDE will pester you endlessly about it. So for a structured task scope, you first have to indicate the strategy. And unfortunately, there are only two strategies available. So one is shut down on failure, which means if any of those tasks fail, hit an exception, shut down immediately and don't complete the others. The other one is shut down on success, where you do the same thing, but if one of them is successful, let's say you're going to multiple shards or something, that kind of stuff. So that is kind of limiting. I could imagine you might have one where you don't shut down on failure, but let's say complete, and then you'll deal with the failures later on. So you first have to define your scope, and then you can just add callables to the scope with scope.fork. And by default, those launch in the virtual thread. And then use scope.join to add a waiting point, and we'll wait here until all of them are done. You can also use join until, as I mentioned earlier, which is interesting for HTTP servers if you know you have a deadline. So you don't do unnecessary work. And then with scope throw if failed, you can propagate exceptions. If the scope threw an exception, you can propagate it here. And yeah, you can get the results from those tasks. So that's a nicer way of dealing with distributing work. An issue we saw earlier was that request scope beans are not propagated. So what we can do about that? For that, we need yet another API, which is scope value. I'm gonna go quickly until this one. So you can set a static scope value defined this way. I say this is scope value of my object context data, which contains my customer name, my tenant name, etc. I initialize it, and then all my requests, whether they are in virtual threads or running in normal threads, you can ask, is this static variable bound for this thread? And if so, you can get the variable. So that's why I have a helper class here, which is application scoped, where I have both my requests scope being and my scope value, and then I just switch between both. If something is scoped, I will return it. Otherwise, I will return my request scope being. Let's go back to this is the last example. So with the scope value API, you can say, okay, set this static variable based on this value that I then get from my request scope being, because this main thread does have access to it. And then I just add my code, my same code of the shutdown of the structured task scope before. And now if they run, they will know it is running for Mario, just because it goes that scope context. Let's see. I'll just continue. So we did those. Those are my backup slides, just in case disaster strikes. We talked about this one. Another thing we need to do as well is, even though these scope values provide a good way for us to copy, let's say, request scope beans, something else we missed was the MDC, so the multidimensional logging context, so that every time we log something, we get, let's say, our customer ID, etc. We made some different helper functions for those, where we wrap those callable tasks. We set the multidimensional logger based on the context that we retrieve, which might be from the scope being, or might be from the scope value, as well as for our tracer headers. We also retrieve them from the current context and also activate them in the new one. Because this is, let's say, wrapper code, it'll get those values from the code that is initializing the code, and then it'll be evaluated later with those same values. So you might need to do something like this, depending on how you deal with context in your application. This one is also nice to know. You need to enable preview, of course, because of those two APIs that I mentioned. You also want to enable trace pinned threads. It means that if the JVM detects that worker threads are being pinned, it'll throw an exception. We put this in here, but we didn't really encounter it. It seems for our case that it worked fine. You don't have to do everything at once. If you is anyone running reactive code at the moment in a code base that they want to get rid of? Okay. Well, if you would, then know that you don't have to migrate everything at once. You could just start at the API front, make those virtual threads, and then for your reactive code, you can do stuff like await at most, whereas let's say a transition point between reactive code and synchronous, where you're waiting for it to complete, a bit like the Node.js async await, but then still blocking. Avoid using reactive dependencies because, and that's the next point, if you're doing something like this, do look at your logs and group by the thread name. That's how I noticed that because we're still using, let's say, reactive hibernate or reactive rest easy, they were doing code in the event loop. And instead of switching back to the virtual thread, it would remain on the event loop and run our blocking code. So we had to remove those first. And then we noticed that the virtual threads were being invoked more consistently.
In that case, did you just go to the non-reactive hibernate, non-reactive rest?
Yes, exactly. So now they also luckily changed their names. Now I think it's just like say Quarkus Rest Easy, etc. Before it was Rest Easy Reactive or Classic. Like I think they changed a lot of their names now, being that the synchronous variant is now the default. Okay, let's wrap this up. What are some of the lessons learned? So for the state of virtual threads on Quarkus, it works fine, really. I think a couple of weeks or at most a month after the JDK 21 release, I think they published support, and I was very eager for it, so jumped on it pretty quickly. Seemed to work fine. This as well for structured task scope and scope values, even though they are preview, they work fine for us, and they are essential for replacing the multi use case for distributing work. Used for concurrent code for I/O, as mentioned earlier, and for us this was definitely worth the hassle. The error logs are at least clearer. Maybe clear error logs is a bit too much, let's say, of our code. It's much easier to onboard new engineers as well. Of course, we all know that you read code a lot more than you write it. So I think as well, let's say in for the Quarkus itself, I spoke from the authors where they say, the developer joy comes from because writing reactive is fun. It might be, but I don't think it's fun to read, at least for someone, not at least the same joy for those, let's say, who are into it and writing it. I also get the same feel a little bit from code golf. Let's say if you're really into the functional world and using, let's say, a lot of streams, and then you have to combine them, whereas let's say a simple for loop might just do the work as well and be easier to read. So yeah, keep in mind developer experience and the readability of code. It really matters a whole lot. And especially as Bert mentioned, if you throw it over the wall and most people have to read it, good luck explaining, the previous examples that I showed. So it's really worth keeping this in mind and creating some other things for it. Another one is balancing performance trade-offs. So not even just balance performance in general versus developer experience, but even performance within performance. Let's say when Customaite started out about 4 years ago, it may sound better, oh, it's more performant, but how exactly is it more performant? Is it because you can go from 450 connections to 1,000 connections? Well, back then, 4 years ago, when you're looking for product market fit, that isn't really a problem. You're really happy to get those connections even in the 2-digit range. So in that case, this is definitely not a case where performance really wins out on what you need it for. Another one that's very specific is, is it for how much doing counter blocking I/O? Really helps if you're thinking, let's say, of making these major decisions to see where are breaking points, to where is it fine to scale with the current system, because you will need to re-architect systems, depending on the magnitude of order change, regardless. Yeah, thank you for your attention, and hope you're all not too hungry, because now I guess you can get and eat.
Question for you. Is the primary consumer of the application in this case a HTTP client and using standard get post and delete into that endpoint, or a WebSocket or an SSE or something else?
No, it will be HTTP, yeah. So end users using web application. In our case, we use Vue, and then the different Java services would kick in, and they would also orchestrate the work to the client services for the different extraction needs.
So I guess that's why you're talking about the number of concurrent connections. If it's just HTTP, it's pretty easy to handle a lot of HTTP. WebSockets, though, you have to hold the connection persistent for that user.
Correct.
Okay.
So we don't use WebSocket at this time. Maybe some point in the future, but at least for our use case, it isn't necessary just yet. Maybe server-side events might just be enough.
Mhm.
All right.
Other questions, thoughts? Throw something at it.
How it works.
I'm just wondering, I'm learning what from that ecosystem. I'm just wondering why the reactive coding app exists. It's like, looks very complex to read.
Yeah, I think Node.js is a good answer to it, because of the web itself being single-threaded in a lot of instances, and that's where also, let's say, JavaScript developers are used to the fallback help. But then they introduce, async await, which is it looks like synchronous code. It isn't. I think that's a good, between a good fix.
Yeah, so I'm familiar with that concept, but it feels like much easier to read.
Exactly.
And for Java, it was for scale. So it came out of the Netty world briefly, and Vertex was based on Netty, and Netty was invented so Twitter could scale. They had to rewrite it from Ruby to Java. And then a lot of it had to do with the WebSocket. That's what I was asking about, this use of HTTP. WebSocket needed scale, and how many connections could. So that's what, at least how I remember it unfolding. But the team that was Netty worked with us, Vertex worked with us. And one thing I'm curious about, because I stopped paying attention to the Quarkus thing for a couple of years now, focusing on platform engineering and all that. Vertex was the core of Quarkus. So it was always a reactive core layered with synchronous behaviors on top. So I wonder if it's still the reactive core.
Yes. So what I've read about it is that in general, they will recommend, just use synchronous code, etc. But we use Mutiny. So we being, Red Hat Quarkus team, they still use Mutiny, of course, under the hood, and they work closely with Vertex. And that's will say, like, that's how we can gain this and this performance benefits. But you don't have to, because that's the message that I read. Unless you want back pressure handling, but then you need to have, let's say, ecosystem needs to be reactive all the way down, etc. Then that might be a good reason to adopt it.
Your point about the ecosystem one is, I think, super important, because when you say ecosystem, you mean like all the libraries you might use, whether it be struts, hibernate, logs for J, et cetera, et cetera, et cetera. Yes. So that was always a challenge. But again, if you think about the original Vertex and Netty use cases, you were writing your own web server. You didn't use any libraries, right? You're building your own socket listening, multi-threaded responder of some sort. That's what a lot of that technology was invented for back in the day.
Yeah.
So a lot of people just use Vertex straight up for that reason, for some sort of bridge between two systems that has to handle a lot of sockets, a lot of connections.
Yeah, I wasn't in the Java system for a while. So I came back and was like, wait, what's this all about? Yeah. Give me back my simple code.
Yeah.
Yeah.
Just not a question, but just sharing experience. Like about 2 years back, I tried hard to do the reactive way, and I just abandoned because it was too complex in the end. Just to understand how you change things, what you're busy with when it will be called, how you deal with the errors, it was just a nightmare. I just spent more time to reading documentation than producing code in the end. It reads well, but it's so subtle that even though you read well, you can barely understand what it's doing. So I'm happy to see that there are like simpler solutions that you can plug.
Yeah, and I agree with your experience was exactly the same thing going in.
Yeah, it was a bad experience, really. Yeah.
There is an antidote.
Well, sounds like an AA meeting.
Yeah.
But when
Try this thing.
when I saw the code and like the annotation afterwards, I was like so relieved.
So have you guys tried Reactive in Java before?
A bit with the Kafka client, the streaming. It's like inside, so it's actually easy to deal because it's well done. But the Mutiny is like,
It is difficult.
I
Yeah,
thought
if
it
they
was
make
hard.
mistakes.
I worked with the guys who did it. So I would ask Tim Fox questions. I would ask Clement questions, right? So Clement, who's the architect of all this right now, is, come on, I don't understand it. Help me understand this code, right? Even then, it was just tough.
I was trying with both Quarkus Mutiny and Spring Flux. But even in Quarkus or Spring, they were both just the same with that uni and multi and all the other annotations and method names. Just do one thing wrong and nothing works anymore.
Yeah.
And I already knew that if I would have to sell something to my colleagues, they would never have even think about it. So
Yeah, be the
it was
person.
trying and testing and seeing it. Yeah. If you're a regular developer, it's quite a mind shift to have everything working. So if you can just put an annotation on it and it magically works, it would be a lot better.
If you introduce it, you'll also be the go-to person for that many years to come. I think probably for their team, because they still use Mutiny for the Quarkus framework itself. I think, they probably have, let's say, good onboarding and a more stable team, let's say, and their ways of dealing with it. But it's, your mileage may vary. All right,
All right. No more questions.
very good to go.
Thank you.
Thank you.
Thank you.
Your gizmos.
Chris, this is me now.